Alright guys, welcome back. In this video here, we're going to quickly demonstrate two examples from lesson 5.2 homework. And within the example, I'm going to go over a few properties of definite integral. I'm not going to list them out all the properties that you can find them in our lesson, textbook. But as we do this example, I'm just going to state these properties that we have when it comes to definite integral. So in the previous video, we talked about definite integral is just another word for the area between the under the curve between two limits, two x value. So in this example here, we have a graph f of x. So this is the f of x graph here, and we have four shaded region between the graph. We have region A, B, C, and D. Now each one of those shaded region is an area under the curve or above the curve if it's below x-axis, and we're gonna introduce that if the area is above the x-axis, like in A here, so we're given that area A is 1.349. If it's above the x-axis, looks like it goes from A to B, then in this case it's gonna be positive value. But if the area, let's for example area B 2.249, if that area is below the x-axis, so it's above the, it's not below the curve, it's above the curve, but it's below the x-axis, so the value of that is going to be a negative. Okay, and then very similar to D is going to be a negative area as well because it's below the x-axis. And if the area is above the x-axis, then that stay positive. Okay, so the questions ask, find, let's call this part A. Find the area of between the curves under the curve between B to 0. So we're looking at the graph f of x here, B to 0. So B to 0 is from B to 0, right? So if the graph, it looks like this, and then what is the area under the curve from B to 0? Well, from B to 0, we just have this area here, but since that area is below the x-axis, so it's going to be a negative value of that. So we're looking at just the answer for this is going to be negative, area B. So that's going to be negative 2.249. Okay. Now I want to introduce part B for this problem. Part B is going to be a little more involved. Okay. I want to find the area from A to D, okay, from A to D of the graph f of x dx, okay. All right, so what we're going to do here is we're going to introduce the properties of definite integral. Very similar to differentiation. When you differentiate a polynomial, you can just take the derivative of a sum by separate those terms individually and then differentiate each individual term, and that become the derivative of the sum become the sum of the derivatives. It's very similar to integral. So if we look at the area from A to D, we're looking at integrating or find the area from A to B, and then from B to 0, and then from maybe I should use different color here. So from A to B, and then from B to 0, and then from 0 to C, and then finally from C to D. So we're looking at we can break this integral into four parts of the definite integral here. So we look at this as, the integral from A to B of f of x dx plus the integral from B to 0 of f of x dx plus the integral or the definite integral from 0 to C f of x dx plus the definite integral from C to D of f of x dx. So this area here under the curve from A to D can be broken down to four different parts, four different areas, and those are the colors shaded under the graph there. So now let's go into and look at what would be the area from A to B under the graph. So that's going to be 1.349. So this is going to be just area of A plus what will be the area of under the graph from B to 0. From B to 0, the area is 2.49, which is B here. But this area is going to be negative, so we're just going to go ahead and say plus negative B. Okay. Plus, what is the area from 0 to C? 0 to C is going to be the C area. Plus, what is the area, what is the definite integral, or the area under the graph from C to D? That's just going to be the shaded region D, but then the shaded region D is below x-axis, so that's going to be negative. So we're just going to fill in these values here. So A is going to be 1.349, minus B is 2.249, plus C is 5.533, minus D is 1.633, and if we do the math correctly, that should give us the area is 3. Okay, so this here is asking for the cumulative area between the graph, between f of x from A to D. Okay, and then that is the definite integral. Definite integral. That's what we discussed in the previous video. Okay, and then that area is 3. Okay, so the definite integral of the function f of x from A to D is 3. Okay, all right. Let's move on to the next example. So we are gonna use these properties here, or this one that I just introduced there, and then apply to a problem that doesn't have a graph. Okay, so we're just gonna have to go with what we're given here. So we want to calculate this. So this is what it's asking. So that right there is asking for. So it's asking to calculate that. That is asking for the area under the curve, or between the curve, under the curve, from 3 to 7. Okay, so that's what we're asking. Well, unfortunately, we're not given any of those. Okay, we're given something else slightly. We're given the area under the curve of x squared. We're given, the area under the curve of x squared from 3 to 7, so the limit is matching. And then we're just given x squared. And we also given that the area under the curve of the x graph from 3 to 7 is 20. But this right here is different. Notice the limit is from 7 to 8. So 8 is past the 7. That's what we're asking. So this right here is not the correct given information. So what we want to use is these two here to find the area that we're asking to find. Okay, so what we can do is we can look at this and say, okay, the area of this graph here from 3 to 7, we can break that into the two separate integral from 3 to 7 of phi x dx, plus the area from 3 to 7 of x squared dx. Okay, so we integrate these separately. Well, we're given that the area, well, first of all, let me go ahead and just take out the phi there. So we learned this in lesson 5.1, 5.2. So we can factor out the constant in front of the integral. Okay. All right. So now we're just going to plug in what we're given. We're given that the area, let me use different color here, the area under the curve of x dx, or the x graph between 3 to 7, we're given this already, and that's 20. Okay, so we're just going to fill that in. So that means 5 times 20 plus, and then we also given that the area under the curve x squared from 3 to 7, that's 316 over 3. And then we're just going to do the math, and then that's 100 plus 316 over 3. Do this correctly, we get 616 over 3. Okay, so there it is. That's our answer. That's our area under the curve of phi x squared, phi x plus x squared from 3 to 7. In the next lesson, we're gonna have to get these answer ourselves. Okay, we're gonna have to, let's say we're given an x squared function. We can evaluate this and find out what is the actual area from 3 to 7 under the x squared, and that's going to be 316 over 3. So we're going to learn how to do this. I'm going to show you the step to do this. So this is kind of leading to the next lesson. Okay.